The last time we talked about the 3 log laws, okay, which can turn multiplying of the inside into adding, right? And then, or the dividing into subtracting. And also the exponent can be brought down to the front, right? So today we'll look at other kinds of questions that's you also using the law, okay, to help you solve. So for example, like question 16, right? Different from your homework. In homework, there's no numbers, right? Mostly letters, variables. We can do the same thing with numbers. And then once you simplify the logs, then you can use counter clock to evaluate, okay? So we'll look at the first question here, question 16a. So we have 3 laws, right? This one has a subtraction. So how do we simplify using the law? Chris?
What page are we on?
Oh, we are on page 97. So my question is, if you see a subtraction of 2 logs, how do you use the log law to simplify it into a single log?
Is it like division?
Yeah, so how do I write it out?
Would it be log 5 root 175 over root 7?
Yeah, very good. Okay, so the common mistake is to write it as log 5 root 175, because you remember it's division, right? And then you write divided with log 5 root 7. Okay, so this is wrong. Okay, there's no such thing of 2 log dividing, because I still see some mistakes in the homework writing like this, right? So once you simplify it, then the inside can divide each other. Okay, root 175 divided by root 7. Can you tell me what that equals, Evan? The inside. Evan, are you there? Can you tell us what does inside simplifies to?
Let me get my calculator.
Yeah.
A 5.
Okay, so if you without using the calculator, right, then you can divide the inside the number inside the root to each other with each other, then you get 25 in the square root, then that turns into 5. Okay, so you get log base 5 of 5. All right, and then we don't stop here, right? Because now you look at this, we have a base of 5 and the inside number is 5. What does that equal to, Marcus?
Sorry, what was the question?
What does log base 5 of 5 equals to? You have to use the counter clock to think about this question.
Is it 10 to 5 equals 5?
You have to start with the base, right? What's the base here?
Oh, 5, sorry.
Yeah, so you think about 5 to what exponent will equal to 5?
5 to the 10, there's nothing there.
5 to the 10 is 5. 5 to the what equals to 5?
Oh, 1, sorry.
Yes, okay, so the question for this, the answer for this one will be 1. Okay, so once you simplify to the last point, you might need to use counter clock to figure out the final answer. So your answer doesn't have any log. Okay, this part is like in your homework, the one you are handing in today. Let me show you, like these ones. Okay, this is the question 3 on your homework, right? For example, here it asks you to evaluate. So just in your head, you just think about, okay, 2, you have base of 2 here, right? Okay, try again. So base of 2, 2 to something has to equal to 32. Right? So Nick, what does the answer equal? Nick, can you hear me?
30 is that 5?
Yes, okay. So 2 to the 5 equal to 32. So there's no work you need to show, right? You can just, if you do the counter clock in the head, you can just answer equals to 5, right? If you want to show work, then maybe you can write something like this: 2 to the box, right, equal to 32. And then the answer is the 5, right? You're looking for the exponent. Okay, this should be a review from last time we learned about counter clock. Okay, so we're applying here as well. Okay, we'll go back to the same page here. Okay, so I would like you guys to try question B now. Okay, so question B, it has adding, it has subtracting, so you have to apply the laws first, right? Once you get the laws, then you use counter clock. So your final answer will just be a single number. Please raise your hand when you're done.
Hey, Jason,
Yeah, Jenny.
we're doing all the questions, right? Not just
No,
B?
just question B.
Oh, sorry.
No problem. All right, we have a few answers. Waylon, what's your final answers for B?
I got 2.
Caleb, how about you?
I also have 2.
Okay, Eric.
I have 2 as well.
Okay. How's everyone else doing? Please raise your hand if you finished. Okay, so Caleb, can you tell us what does it look like after you simplify into a single log? What's inside the bracket?
Oh, log base 5
Mhm,
with 1000 times 1/4
mhm.
over 10.
Yeah, very good. Okay. And Daniel, what does it simplify to for the inside?
It becomes 25.
25. Okay, very good. And then from there, you just do counterclock in the head. 5 to something has to be 25. So answer must be 2, right? 5 squared. Okay. So please raise your hand if you finish question B or finish writing down the steps for B. And then we're gonna look at question C together. Okay, Evan and Jocelyn, once you finish writing down, you can raise your hand. And by the way, a news for the May classes. Remember, I told you guys we will be going back to in person, but it's not happening anymore. The school board says don't come back in May, so maybe in September, okay, instead of May. Okay, Justin, are you done?
Yeah, I
Yeah.
forgot to put my hand up.
Okay, all right. So let's look at question C. Question C, you have a radical, right? Radical seventh root. So for this one, we can rewrite it first, okay? Because with the root there, that makes it looks difficult, right? So the seventh root, we can write it as an exponent, okay? So how do I write seventh root in exponent, Angela? Angela, are you there?
Yeah, 243
Yeah.
to the power of 1/7.
Yes, very good. Okay, so the 7 goes to the denominator. Now, once you have an exponent there, we have one law, right? One of the log law can help us deal with the exponent. So, Philip, which one is that? Which one has the rule for exponent?
Log of power.
Yeah, and what can we do with it?
You can change the exponent to multiply the log.
Yes, okay. So you can bring it to the front, right?
Yeah.
So you will have 1/7 times it by log 3, 2, 4, 3. So you can just deal with the number that doesn't have the root, right? Makes things easier to think. So now you ask yourself 3 to what, right? In your head, 3 to what? Exponent can give you 2, 4, 3. Okay, I'll let you guys figure that out. Once you figure that out, then you can simplify together to get the final answer. Okay, so that's what you can do with the when you see radicals, right, or exponents, and you can bring it down. Okay, make the numbers smaller too. Okay, please raise your hand if you have final answer for this one. Okay, Susan, do you have the final answer?
5/7.
7?
5/7.
5/7, yes. Okay, very good. So that bracket part is 5. Okay, 3 to the 5 equals to 243, right? And then you multiply by 1/7. Okay, please raise your hand if you finish this one. All right, so last question looks really unique, right? You have a bunch of log in the exponent part, okay? And then there's a base of 7, right? This 7 is the base, right? This whole log here, let me just highlight that, right? The yellow highlight, that whole thing is the exponent. So let's simplify that exponent first and then see what to do with the big 7, okay? So I would like you to apply a log law, okay, to that exponent part. Simplify it as far as you can. Okay, simplify into a single log. Okay, we'll just use a green. Okay, simplify. So I would like you to turn this into log base 7 of something, okay? Simplify into a single log. Okay, please raise your hand after you've done simplifying. So your final answer, right, for this part, the simplifying part, just it will be a fraction inside, okay, something over something. Okay, Marcus, do you have anything?
I'm not sure if it's right, but I put log 7 and then 2 times 3 over 2.
2 times 3, it's not 2 times 3. The over 2 is correct. The 2, right, for this 2 at the front, you have to use the power, log of power. 2, you have to bring it back up to the exponent. Okay, hold on. Yeah, over here. Now remember, if it's an exponent, you can bring it down to the front. So this one, you need to bring it back up. Okay, let me write the step first. Okay, so first, you have to bring the exponent, right? Bring the front number into exponent. Log 7 of 2. Okay, Marcus, do you get what I mean?
Oh yeah.
Yeah, okay. And then, so now after that, what do you do?
Wouldn't it just be log 7 3 over 2 over 2?
3 over 2? Over,
Wait, 3 to the power 2 over 2?
yes, and what's 3 to power 2?
9. So
9.
9 over 2?
So it'll be 9 over 2. Okay? Right, please raise your hand if you got to this step. So if there's a number at the front, you need to bring it back up before you can simplify the log, okay? So it's, the 2 has to go to exponent first. Okay, Evan and Marcus, Susan. Okay, so once you get to this point, then we can replace that with our exponent, right? Because it's being shortened. So it'll be 7, the big 7, and then to the log, which is the green part, base 7 of 9/2. Still looks complicated here, right? So over here, we're gonna introduce another law to help us simplify this, okay? Because our final answer cannot have any log, right? So before we answer this one, we go back to our list of laws, okay? Here we're gonna look at law number what? Which one looks like the question? Anybody? 4, 5, 6, which one of the 4, 5, 6 looks like the question we were doing? Do you recognize? Yeah, Daniel, which one?
Number 5.
Yes, very good. Okay, so number 5, if you look at 5, right, it says if the base, which we had was 7, right? 7 to the log base 7 of, that was t was the 9/2, right? So b is the 7, the t is 9/2, right? If it ever looks like this form, it would just simply equals to t. So what's the answer for this one, Philip?
9/2.
9/2. Okay, so we can go back to here and say the final answer is 9/2. So with the help of the law, right, we don't have to deal with this complicated form, right? Whenever the base are the same, then it just equals to whatever that goes after goes in the bracket. So this, I call it a base to base. You have base of 7 to the exponent of base of 7 again. Okay, so why does it work, right? How come it can simplify to that? Okay, so let's go over where the law come from. So suppose I started with a random base, okay? Well, let's just get a random number first. So let's say, we'll pick some easier number, okay? So let's say we have base 2. Okay. And then log base 2 of 8. Okay, we want to figure this out. What does this equal? Okay, can you guys write this down first? All right, so this part is our exponent. Okay, so I just make up something randomly. At least it's not like 9/2, right? Something looks easier. Okay. Well, before we do something else, right? Because I chose a number that's easy to evaluate. For the green part, we could use our counter clock. Yeah, Jenny, you have a question?
No, I was just wondering if the answer was what I thought it was.
Which one?
Is
The
it
one-
8?
Yeah,
Yeah.
yeah, this one answer will equal to 8. Yes, okay. But we're gonna prove it, okay? So for the exponent part, right, the green part, if we use counter clock, 2 to something has to be 8. So this green part will become a 3. Right, so equal to 8. Okay, but let's say if it's not 8, if it's something that's not something that we cannot use counter clock. Okay, so let's say 5. I put a 5 there. then how can I show that it will equal to 5? Okay, so here is what we are going to do is we put log on both sides first. This is called log on. Okay, we put the log on both sides. Okay, so the red thing is the new log I put on, and then I will choose log to have a base of 2. Okay. So all I did is put the log on both sides, so they still stay equal. Okay, it's kind of like if you have 5 equal to 5, if I put a square root on both sides, it will still stay equal, right? So if I apply the log on both sides, it won't change the original equation, right? Left side still equal to the right side. All right, everyone got this step? Once you put the log on both sides, on the left side, the green part, which was the exponent, then I can bring it down to the front because of our log of power, right? If there's an exponent, the third law, right, I can bring it down to the front. So this exponent, the green part, I can bring it to the front. So it will look like log base 2 of 5, right? That was the exponent, right? And then you have the log times it by log base 2 of 2. We use the blue. Okay, right side, nothing happens. Okay, it still stays as log base 2 of the box, the mystery number. Okay, can you raise your hand after you write this down? Okay, so if you look at this statement right now, this line, which part can become 1? Waylon, which part becomes 1?
Can you repeat? I was just like away from a computer.
Yeah. So in this line, right, the third line here, which part of the equation becomes 1? Simplifies into 1.
The bottom part of the log.
Huh? Which part?
Like the bottom 2, I think.
You have 1, 2, right? These two parts. Which one equals to 1?
Oh, the second one.
Yeah, second one. Okay. Base 2 to the 1 equals to 2. Okay. So this part equals to 1. Go to here. Okay. I ran out of space. So equal to log base 2 5 equals to log base 2 of the box. Right? Because this part becomes 1. Okay, when the base and the inside number is the same, equals to 1. So now both sides, they just have 1 log base 2, right? So you can also log off, right? You can log on, then you can log off. So you get 5 has to equal to the box, the mystery. So you can do the same thing with any numbers, right? It will tell you what that empty box is. So you will see that no matter what number you change to, right? The inside, when the base are the same, it's just equal to whatever that's inside the log. Okay, so that's our new law, okay, for the special case. All right, so we're gonna move on to something else. Okay, next part. Another kind of question they will ask you to use the log law, okay? So like over here, it asks you to evaluate. So your final answer has no log. This part is not evaluating, it asks you to determine an expression. So your final answer still has no log, but it won't be a number, right? Because an expression means it still has letters. So what letters are in there? We could either have the K, right? Because it says log 5 is K, log base 2 of 7 is M, right? So your final answer either has K or M. Okay. So let's look at our first one, see what that means, okay? Which to see what does it mean by expression. So you see this one, the inside you have dividing, okay? So compare with what we had before. Before was more than one log, and then you turn it into single log, right? Now, instead of more than one log, they give you a single log. So I guess the only thing we can do is to go back to write it out separately. Okay, so we can apply the laws in two directions. You want to expand, okay? Expand using your log law. Okay, so how do we expand this one? Callum, can you try this one? Which law do we apply for dividing the inside?
Oh, I think you got to put it as log square root of 5 minus log 1000.
Yeah, very good. 1000. All right, so now we have one of the log has a radical, right? Remember we have a rule. We have one of the law that can deal with radicals. All right, Nick, what do you think? What can we do with the square root of 5? Which law can we apply?
I'm not sure what it's called.
Well, we have the one we used was here, I think. Where did it go? Oh, here. Question C. Right? For the previous page, the seventh root, what did we do?
You turned it into like to the power of 1/7.
Yeah, and then what do we do after that?
And then like do 1/7 times the log of
Yeah, so you bring the exponent down. So that is called the log of power.
okay.
Right? You have an exponent, then you can bring it to the front. So how do we do the same thing for this one here?
So you bring 5 as 5 to the 1/2.
And
then do like 2 times 5.
2 times 5?
Oh, sorry, 1/2 times
1/2 times what?
log 5.
Yes, very good. Okay, so you can always do that for any kind of root. Okay, write it as exponent. Okay, so I'm just copying the log 1000, nothing happened there. All right, any questions? So why do we want to do that? Okay, once you get to this point, then you can look at our expression, okay? The one that I underline with red. Log 5 can be replaced with K, right? Log 7, base 2 of 7 is M. So this one doesn't have anything to do with the base 2, right? So the only thing I can replace is the log 5. So you get half times K, right? Because from the question it tells you when you see log 5, it will just become K. And then the second part, You cannot leave the log 1000 there because your answer cannot have any log. So what does log 1000 equal to? Chris?
Minus log 1000.
Yeah, what does that equal to? 1000, can we simplify with log 1000? Think about counter clock.
Is it 1000? Is it 10 to 3?
Yes, very good. So minus what? What do we put? Minus,
Log 10 to 3?
now over here, right? The base is 10, right? Right? Log
Yes.
base,
Minus 3?
yeah. So 10 to something equal to 1000. You say it's 3, right? So this whole thing will just become 3. Got it? Okay, so you don't need to write log anymore. Okay, you can think on the side. Okay, it's not part of the steps. Think on the side, log base 10 1000. What does it equal? Right, you put a question mark, then you use counter clock. 10 to the 3 is 1000, so that question mark is 3. So you replace it, but this is not necessary to write it out. You're supposed to do it in the head, right? Do the counter clock in the head. If they don't show you the base, that means it's a base of 10, okay? An invisible base. Just like a square root, right? If they don't write anything outside, then that's a square root, okay? Invisible ones by default. All right, so that's the final answer that we want to get to. Oops, okay. So your final answer, this is called an expression, all right? Expression. It has only numbers and the variable, okay? No log. So please raise your hand if you have done this question. All right, so let's try question B, okay? And this time is for you to do it by yourself, okay? Very similar. It also has to do with 5, I guess you can tell, right? From the look of it. So final answer only has K or numbers. All right, so I'll let you guys work on that by yourself. Okay, expression has no log. Okay, once you got an answer, please raise your hand. right? So far, only 2 people got the answer. Let's check your steps, okay? See what you've done so far. Okay, Eric, did you do anything for your first step?
Oh, I have log 125 minus log 5 root 5.
Okay, 125 minus log 5 root 5. All right. And Marcus, did you do anything after this line?
I put log 125 minus log I'm not sure. I just put 5 times 5 to the power 1/2.
5 times 5 to the 1/2. Yeah, so far it still makes sense. You tell me what you did next.
Oh, I didn't get anything else after.
Okay, then let's talk about it. What do you think we can do next?
I think can you just times the 5 together, so 25 1/2?
Okay, so think about this one, okay? If I have 5 squared times it by 5 to the cube, what do you think we can do?
Add the powers together.
That's right, okay? You can only add exponent. You never multiply the base together. Okay?
Okay,
Okay, so tell me what you get after you add them.
it's just 5 1/2.
Okay, you need to add them up, right? What's the exponent for the 5?
Oh, 1, sorry.
Yeah. So what do you get?
1/2.
1/2?
Minus like,
You
this
have
is 1 point.
5 to the 1, right?
Oh yeah, so it's like 1.5.
Yeah. Or you can write it in fraction. What over what?
1 uh uh wait, 3/2.
3 over 2. Okay. 5 to the 3 over 2. And then for the 125, can you also write it with a base of 5?
5 to the 3.
Yeah, very good, right? Because everything has to do with 5 here, right? So we can write it as base 5. Okay, and Philip, did you do anything after that?
I turned the first log into 3 log 5.
Oh, okay. So you bring the 3 to the front, right?
Yeah.
Okay, so 3 log base 3 log of 5, yeah.
And the second one into 3 over 2 times log of 5.
Yep, 3 over 2 times log of 5. Very good. Okay, so that's what we want to get to, right? We want to make sure we can see the log 5. So log 5 is right here, and now the log 5 is there. So Angela, what can we do now?
Combine them?
Okay, how do we do that?
I'm not sure.
You have log 5 here, right? What did
Yeah.
we do before, right? In the previous question when we see log 5?
Turn it into, like, plug in the K.
Yeah, because question tells us when you see log 5, it just equals to K, right? So can we do the same thing here?
Yeah,
becomes
3 times k minus 3 over 2 times k.
Can we simplify more? 3k minus 3 over 2k. There's no more log now. How do we simplify it?
Make the 3 into the same fraction.
Yeah, okay. You can simplify and let me know what you get.
Is it just 3 over 2k?
3 over 2k, yes. Okay, just combining the like terms, that's all. Okay, so 3 over 2k is your final expression. All right, so you can see that the final answer for this section doesn't have log at all. Okay, kind of similar to here, right? Has no log, right? But then your answer is just numbers. But this one, it still has variables because of the question, right? It tells you to replace it with the k, the letter. Okay, please raise your hand if you finish question B. Let me know if there's any steps that you got lost, okay? Not sure what's happening. Okay, Marcus and Waylon, do you need more time to write this down? Okay, so look at question C now. Question C has log base of 8, right? And the inside number is a 49. So does it have to do with k or the n? What do you think, Chris?
Pardon?
This question C has to do with the k or the n?
The M.
The what?
The M.
How do you know that?
Because I feel like 49 is connected to 7 in a way. 2 and
Okay.
8 are somehow connected, but I'm not sure how it's connected.
Yes, yeah, okay, so you can see a little bit of connection of 49 and the 7, right? And then the 8, right? Something to do with the 2, right? Sort of, right? It's less connected with the 5, right? 5 to something, it will never become 49 or 8, right? So you have to have this kind of sensitivity, right? To spot the connection between the question and the clue. So how can we make them connect? So for this one, we need another law, okay? So let's go back before we look at this question again, right? Let's go back to our list of law. So you can see that the for each question, right, it can help us to understand when to use the law, right? If you see base to base, then it's number 5, okay? So this one, question number 4 is called the change base. Change base means we can use it to change to any base we like. All right, so if you look at the question we are dealing with, we have log base 8 of 49, right? Let's copy over here. Log okay, log base 8 of 49, okay? That's where we got stuck. Now, if we apply the change base, if you look at the rule, if you have here you have a base of b, right, which is 8. I can change to any base of c by writing in fractions. Okay, by splitting into 2 log with the new base. So the c is the new base that you want to change to. Okay. So from the question, because Chris said this one probably has to do with the m, right? So the new base that we want to use is 2, right? The base up there is a 2. So you want to change the base into 2. So we split it, right? Because of the law, we split it into 2 log, 1 log at the top, 1 log at the bottom. Okay, and our new base is 2. Okay, and okay, can you raise your hand if you follow up to here? Now, what number should go on the top? Susan?
Wait, could you explain why we get a new base of 2?
We choose the base of 2 because the question has log base 2 of 7, and the base 2 has more connection to the 8, right? Because 2 to the 3 will be 8. That's why we choose base 2.
Okay.
Okay, we won't choose 5 because it's 10, right? 10 doesn't connect with the 8 more than the 2. Okay,
Okay.
so what number can go up there in the numerator? Right, you look, compare with the law, right? The law change base rule.
49.
Yes, very good. The 49 is like the A, right? A, B, C, A. Right? What about denominator?
8.
Yes. Okay, everyone follows up to here. How we get the 49 and the 8? Can you raise your hand? Okay, so there's 8, right? The original base, it goes to the bottom. And then the big number, the 49, goes to the top. And the base, you can choose anything. You can choose 2, you can choose 5, you can choose 11, okay? In this one, we choose 2 because the question give us a hint to make it into 2, okay? So we're gonna do the same thing. We'll come back to the law again later, okay? Right now, we just want to apply it first. Okay, Chris and Marcus, do you have any question how we get to this point? Okay, so go back to here, right? Go back to the question. I'm gonna do the same thing. We change base into 2. Okay, do this because of our law, okay? Thanks to the law. So we have 49 on the top, 49 and 8. Right. Now we can still do something. The 49, like Chris told us, right? 49 has to do with 7. How can we rewrite 49 using 7? Caleb, how do we rewrite 49 using 7?
We can change it to an exponent.
Yeah, how do we write that out?
Log base to the 7 to the power 2.
Yes, okay. Now we're gonna do extra step here. The 7 to the 2, I can bring it to the front. Okay, using our log of power. Okay, I won't go too fast, okay? I'll still write it out, 7 to the 2 first. Okay. Now for the denominator. Eric, what can we do with the denominator? Log base 2 of 8. Can we do something about it?
You can rewrite it as log 3, right? Or just 3.
Yes, just equal to 3. If you are, if you remember the counter clock, right? So 2 to the something has to be 8. And that something equals to 3. So just equal become 3. Right? We want to simplify as far as we can, right? So that counter clock thing is very useful. Okay, can you raise your hand if you caught up to here, understand to this step? All right, now we apply the log power, right? 2 can go to the front. So become 2 log base 2 of 7. So now we can finally see we have log base 2 of 7. And that thing is gonna replace it by our m, right? So we get 2m over 3. That's our final answer. All right, so once again, we get an expression, and your expression shouldn't have any log. Okay. So this is called the change base rule, okay? Change base law for log. All right, so let's go back and take a look at the law again, okay? How come it works? Just like the base to base, right? We showed an example how come it works. They equal each other. So same thing with this one, okay? We want to show that the left side can equal to the right side. Okay, so let's say we make up an example again, okay? So just a random example. Okay, so let's say we have log base 8, okay, and then let me see. Okay, log base 8 of 25, okay? I just make up something differently. Equals to something. We call that x, okay? So I just make it up, right? So it can be any number. So let's say if I change this into exponential form, okay, doing the counter clock, 8 to the x equal 25. Okay, so we can write it as 8 to the x equal to 25. Right, nothing changed, right? I just rewrite the form, okay? They are still the same thing. And then what's new is we are going to do log on, okay? So we put log on both sides. We've done this before, right? On the last page. When you log on, you can choose any base. So I can choose like base of 7, if you like, right? You can choose base of 10, right? If I don't write anything, it will be base 10. You can choose anything. Okay, so here I chose 7. Okay. So once I do that, then the left side, because it has an exponent, then I can bring down the exponent to the front.
Hey, Jason, I have a question.
Yep.
Why did you choose log 7? Like,
We
was it
can
just
choose
random?
Yeah, random. Yeah, we can choose.
Okay.
anything.
Okay.
Yeah, so just like the last question, we chose log 2. Okay, if you like, you can choose log base of 5. Okay, last question we chose 2 because the question has a base of 2 that we want to use. Okay, so you choose it depending on the scenario. Here I just chose a random number. It'll be log, so x, I bring it down, it'll be log 7 of 8 equals to log 725. Okay, please take a look at each step. Does anyone have questions so far? Can you raise your hand if you caught up? Okay, and then the final step that we are going to do is to isolate the x, right? Remember I put the x at the front. I want to isolate that. So to isolate, we will divide the log 8, right? Log base 7 of 8 on the left side. So divide both sides by log 7 of 8. So the x is by itself, so it looks like this now. Okay, do you follow here? So this is x, right? And x is equal to the log base 8 of 5. So if you take a look, this part, right? All the pink box, they all equal each other. So I have changed log base 8 of 25 into a new base. The new base that I choose is 7, right? I chose a new base of 7. So you can see through the steps, right? You can turn this into any base you like. This is just a proof, right? When you're actually doing the changing base, you don't need to go through this whole step, okay? You just apply the law like we did in the question. Okay, I'm just trying to show you why they equal each other. Okay, how come this rule, it doesn't just drop off from the sky, right? Somebody did the work for us, right? Figure out this rule. Okay, can you raise your hand if you got this down? Okay. So just like every law, right? There are logical reasons, okay? How come they equal? Even they look so different, right? Left side, right side. All right, so please raise your hand after you finish writing these down. So no magic here, okay? There's a magic revealed. So if I don't show the proof, it looks like magic, right? How come it equals to a new base? How come you can split 49 to the top, 8 put it at the bottom? Okay, Chris, Eric, and Evan, do you need more time to copy down? Okay, so that's all for the log law, okay? Now we're gonna look at equations. So we cover all the log law that we need, okay? The most common ones. So the second part, right? What was the first part? First part, how come it says 2? That should be 3. Okay, so first part was a changing log, right? Counter clock. Second part is the log law. This should be the third, okay? I think there's typo here. This should be number 3. Okay, number 3 is to solve equation. Using log law. So once you have learned the log law, okay, these one are pretty easy. You have 2 log are adding each other up. Okay, solving equation means to find x. Okay, find x. So we are not just simplifying. We want to find what x will make the left side equal to the right side. So on the left side here, we have adding, right? So we can use our first law. When you do adding, they can multiply together, right? We can turn it into a single log. So what should go inside that square bracket? Okay, Waylon, what do you think should go into the square bracket here?
3x plus 1 and x minus 3.
Yeah, and they are multiplying together, right?
Yeah.
Okay, very good. Right, so using our first law for adding, right, we can turn it into multiplying on the inside. Once you get to this point, we can start using our counter clock, okay? You can only do counter clock only if it's one log. So 5 to the 3, right, should equal to the inside. Okay, what is 5 to the 3? Curious? 5 to the 3. Yeah. Huh? What did you say, Chris?
125.
Yes, 125. Okay. So 125, right? 5 to the 3 is 125 should equal to the inside. Inside 3x plus 1, x minus 3. And then we can expand this, okay? Expand the brackets, multiply that out. All right, so Evan, please help us expand the brackets and let me know, okay?
Wait, I just expand the brackets, right?
Yep, just expand the bracket.
Okay, 3x squared minus 8x minus 3.
3x squared minus what?
8x
8x
minus 3.
minus 3. Okay, equal 125. Okay, and then we're gonna move everything to one side. Once you get to here, this is called a quadratic equation. Okay, this is from your grade 11. Okay, quadratic equations. 3x squared minus 8x minus 128. Okay, quadratic equation. So how do you solve from here then, when you have a quadratic equation? Does anyone remember what to do?
Do you draw like the 2 vertical lines?
Okay, we call that a factoring, right?
Yeah, that thing.
Very good. Okay, and Jenny, did you want to say the same thing, like factoring?
Yeah, that's what I was gonna say.
Okay, so yeah, turn it into two brackets, all right? So please raise your hand after you're done factoring. Yeah, 128 is a kind of big number. Might take more tries to find it. But for the 3x, for sure, we know it can only break down into 3x and x, okay? So please raise your hand after you got the pairs, the brackets. Okay, Caleb, can you tell us one of the bracket?
Three x plus 16.
3x plus 16. Okay,
And
and
the x minus 8.
okay, I was gonna ask another one. Okay, good. Yeah, that's correct. Okay. So those are the two brackets. So from there, we can solve for x, right? You make each bracket equal to 0, isolate x. Right, so Nick, you can help us get the x then.
Oh, 1 sec.
Yeah.
Is it x minus 8 times 3x plus 16?
Yeah, we got that already, right? So now we want to.
Oh, sorry, I was looking at the wrong spot. Okay. So is it x is equal to 8
Mhm.
and negative 16 over 3.
Yes, very good. Okay, everyone got to here. Does anyone have trouble factoring? If you find that the factoring is like too hard to find, right? Because the number is quite big, you could also use quadratic formula, right? To find the x directly, but you need to remember the formula as well, right? So you could also use this one, negative b plus minus. Does anyone remember? Eric, do you remember the quadratic formula?
It's negative b plus minus square root of b squared minus 4ac divided by 2a.
Yes, very good. Okay, so you can also apply this to our quadratic equation. Okay, the ABC, you plug it in, then you will get the 8 and negative 16 over 3. I just find that this, usually I only use this if it's like a decimals, there's decimals involved, right? Because you can factor it. Otherwise, I always go for factoring. Okay, once you get to this point, okay, I cannot stop here yet. Okay, there's something I need to mention on the side. Okay, so make a note. If I have log with any base, okay, it doesn't matter. Let's say I choose 2, okay, and then of something, whatever, okay, equal to whatever, okay, because you have a base of 2, 2 to the something has to equal to the inside, right? Inside, I call this inside. Okay, 2 to the something, right? If you use counter clock, no matter what number you put into the question mark, the inside number can never become a 0, right? For example, if I put 5, then the inside will be 32, right? 2 to the 5 equal to 32. Let's say if I put a 0, 2 to the 0 equals to 1, right? So inside will be 1. Everybody follow? Okay, let's say I choose -1. What's 2 to the -1? Evan? Oh, Evan, I don't know if Evan's back. Marcus, 2 to the -1, what does that equal?
It's not 1/2.
Yeah, 1/2, right? So no matter what number I choose, there's no way I can make inside to be a 0. Also, it can never be a negative number, okay, for the inside, okay? So you need to make sure the inside is always positive. Okay, whatever that's in the bracket has to be positive. So before we state our conclusion, okay, we got our 2 answers here, right? We have the 8. I need to plug it into our question. The 3x plus 1, the x minus 2, those are the inside, right? You need to make sure it still makes the inside positive. So for example, if I check the 8, okay, so here we are checking, right, on the side, check. When x equal to 8, then 3x plus 1 is what? 3 times 8 is 24, is 25, right? Plus 1 is 25, so that one works, okay? And then for the other one, 8, x minus 3, okay? The second inside is 5, so that also works. So that means we can keep the 8. Okay, we keep it because it makes the inside positive. All right, now let's check the other answer. The other answer that we got is x equal to -16/3. Now we don't need to check both, right? As long as one of them failed, okay, then we know we cannot keep it. So let's say if I use the x minus 3, -16/3 minus a 3, minus a 3, if we get common denominator, is like 9/3, right? So that's like what, 25, -25/3. So this one is a fail. So this we have to reject. Okay, we don't reject it because it's a negative answer. Okay, we reject because it makes the inside negative. Okay, so this is the last thing you have to do before you box your answer. All right, can you raise your hand if you understand how to check? So remember to check your answers always. Okay, Eric, Marcus, and Wayland. Any questions about checking the answers? Okay, so I will say one more time, right? If you get an answer of negative, it doesn't mean you need to reject. You need to put it back in to make sure inside is positive, right? So for example, like if for question B, you get an x equal to -2 at the end. But then you plug it in here, -2 plus 4 is 2, so it's okay, right? But if you plug it into the other one, -2 minus 2 is -4, then this is not okay. Okay, as long as one of them failed, then you cannot keep it. Okay. Okay, I think we are due for a break. Okay, let's take a break for 15 minutes, and we'll meet again 11:15.